Here's my Module 5 mastery assignment. First topic is Euler's method. It's a method of estimating a solution to a differential equation by using the differential equation and a given point. I like to compare it to like a Riemann sum, where you're kind of moving along an interval and then getting a number. So problem 1, given that dy dx equals 3x minus y, and f of 0 equals 1, estimate f of 2 with 2 equal step sizes. So what this is asking me to do is go from 0 to 2 in the x value with 2 steps. So I write that out here. And I like to create this chart when solving them. So we have the point x, y, some change in x, delta x, dy dx. And this really didn't seem clear to me at first, but it's delta x times dy dx, and that cancels out the dy dx's over here and leaves you with just dy. So then you can say your next point is x plus delta x and then y plus dy. So let's plug in these points into our equation here. We have 3 times 0 minus 1, so we have negative 1. Negative 1 times 1 is 1. Then we say 0 plus 1 equals 1, and 1 minus 1 equals 0. Move this point down here again. Plug this into the equation. We get 3 times 1 is 3 minus 0 is 0. So we have 3. 3 times 1 is 3. Then we add it back into our y and our x's to get the estimated point of 2, 3. So f of 2 approximately equals 3. Next topic are separable differential equations. It's a differential equation that can be solved by separating out the variables and then integrating. They're mostly used on equations where the two variables are multiplied or divided. So like the last problem of 3x minus y, separating that out really wouldn't work out that well. So the problem for this is find the particular solution to dy dx equaling x squared times y minus 4y all over x plus 2, with the initial condition that f of 0 equals 5. So here I just rewrote it out, factoring out the y, and then I factored out x squared minus 4 even more. Now what I see here is I see x squared plus 2, so I can cross that out. So now we have dy dx equals y and then times x minus 2. I'm going to start moving things over by multiplying both sides by 1 over y, and that cancels out this y. Then multiplying both sides by dx, which cancels out the dx over here, and then those y's cancel. Then we're left with dy times 1 over y equals x minus 2 times dx. Now to get rid of dy dx, we integrate both sides. 1 over y integrates to the natural log of the absolute value of y. Then this integrates to x2 over 2 minus 2x. Making sure to remember the plus c. Now after that we had a natural log on one side. So we got to raise both sides now to e to cross out the e's here. So we're left with y equals e to the x squared over 2 minus 2x plus c. And well, we're going to solve for c. So I kind of want this kind of on its own. And remembering rules for powers. If we have a plus sign in the exponent, we could just bring it out and say multiplied by. So now we're left with e to the x squared over 2 minus 2x times e to the c. Now this is a constant to a constant, which is just another constant I'll call big A. Now we'll solve for a by plugging in 5 for y and 0 for x. This leaves me with e to the 0 minus 0, so 0. E to the 0 is 1. That leaves us with 5 equals a. Plugging this back into the equation, we get y equals 5 times e to the x squared over 2 minus 2x. And that's our final answer to this problem.